Today we are starting lecture 7 with energy storage. Now, I already explained you why do you need energy storage. Unfortunately, energy cannot be stored in a bulk. So, as and when you need it, you have to generate it. However, as we were talking about various renewable energy sources, since they are fluctuating all the time, and if there is any problem, so need to have a backup or storage. So, the work R&D started in right earnest in energy storage area. In fact, there have been some PhD thesis in our center for energy storage, especially hydrogen, and in chemical engineering department, fuel cells, batteries, etc. However, the energy storage is always costly. It is not cheap to store energy. It will cost you money. So, economics had to be worked out. Whatever you may do, you cannot ignore economics. Of course, we have already done pump storage. We have talked about it. All of you know that how pump storage plant works. It is generator, turbine and motor and pump reversible set. During offload, it works like a motor and pump, and during peak load, it works like a conventional hydro plant. Besides that, we have a compressed air storage in the form of compressed air. Well, the detail you can always read in any good energy book, how this various storage schemes work. There is a heat, hydrogen gas. In fact, hydrogen gas will be so popular slowly that even your scooters will run on hydrogen. You will have a cylinder along with your scooter with the hydrogen gas, and it may work out to be cheaper one day. Secondary, batteries. This everyone knows what is batteries. You know, any telephone exchange or your car batteries or even inverter, it needs a battery. Each inverter, the half the cost is of Exide battery. Flywheels, I think flywheels you must have studied in your utilization of electric energy course in your undergraduate, how flywheel stores energy, and those exponential curves you must have drawn, these various cycles, and superconducting coil. Of course, there is a magnetic storage as well. Some Professor Mohan of Wisconsin University, he has done a lot of work in SMES. You must have, yes, you must have known about it. There are so many things. There is an explosion of knowledge. In fact, this 35-hour or 40-hour course is not enough to tell you the full story about everything. That is why we are not going in detail, because we have to give you a general idea, so that if you get interested in particular topic, you can always take it as a minor project or a major project, or do your PhD later on. Now, when do you really need storage? Besides failure of a plant, you need storage when there is a shortage. When do you go for taking a loan? Nobody likes to, everybody hates to take loan, but sometimes in life you have to, when you get short of money and you have to have a daughter's marriage or some medical urgency or something, then only you go and ask for a loan, otherwise you don't. So, when do we draw from a storage? That is your bank, when there is a shortage, otherwise why should you do that? And shortage will come only during your peak loads, because at that time there may be a case where enough generation is not available. Sometimes you may find using gas turbines may be a costlier option. I have already talked about gas turbines in one of earlier lectures, and I also told you why do we need gas turbines. Though they are less efficient than conventional steam power station, 30% as against 40%, but they are quick starting. But here is a proposal that rather than starting gas turbine, use your storage. That is what this means. The storage sometimes serves a better purpose to serve the peak loads rather than starting gas turbines. Of course, if you have both you can always work out economics. Now, in case of secondary batteries, which is really the oldest way of storing energy, all your toys, your electronic goods, your what you call transistors, 2-in-1s, Walkmans, calculators, everywhere you use batteries, and that is nothing but your energy source. Now, in fact, the lead acid batteries were invented way back by some scientist called Plante in 1860, almost 30 years before the electricity got generated in a bulk way by Edison. The first bulb was lit. Electricity is very old story. You must have known that ebonite glass rods, static electricity. You must have read it in your physics courses. There are battery powered vehicles. I already talked about it. In our IDDC center, Professor Rukaswamy has done a lot of R&D in a bus, which is electric bus. In fact, there is an electric bus service going on between Fatehpuri and Lal Killa, and that is just to make people aware how pollution can be avoided by using battery driven buses. So, battery powered vehicles are available, they are running on the roads. Even that electric car Riva I mentioned some time back, being manufactured in Bangalore, it is also it is practically the batteries. Well, the latest is sodium sulfur battery, which is 200 watt hours per kilogram, that much energy. And as I told you yesterday, the material science is one of those 5 important areas which have done tremendous progress and have changed the world, the material technology. Just looking, copper was replaced by aluminum as a conductor, and so on. The material has made a lot of difference. It has made things quite cheap. That is why we have a material science center also in our IIT. It is called polymer science, but originally its name was material science. Now, naturally the aim of any researcher, any scientist or any energy engineer will be to develop such a battery where you get more output and storage per unit weight. That is why each battery is different. Everybody claims ours is, you see the advertisements where one battery fails in between, other battery only reaches the victory post. That sort of advertisement you must have seen. So, everybody claims that his battery is better. Now, fuel cells is another way of storing energy. Now, a lot of work is going on in fuel cells throughout the world. You must have read somewhere or seen there is a car in Japan which was developed very recently using fuel cells. Now, of course, the cost at the moment is 2 crores. Now, 2 crores car nobody will buy in India, but tomorrow who knows, it may be 2 lakhs. This tomorrow I mean some number of years, which is not known. In fact, what is done in fuel cell? Chemical energy is the input and it is converted into electricity directly with no intermediate combustion cycle, and that is the beauty. There is no intermediate, something like MHD, there also there was no intermediate change of cycle, which is there in a conventional conversion process like chemical to mechanical, mechanical to electrical. Now, what we do here? We bring in hydrogen and oxygen. This is a simple chemistry. All of you have done this chemistry in your 8th class or 9th class or 10th class, and this gets combined and naturally H2O, water, plus electricity, and this is what electricity is used. These are porous electrodes. Electrodes I have not shown here, and they allow hydrogen ions to pass. Of course, they are costly. I just now mentioned you. Anything which in its initial years, in the beginning years, are always costly, but as the time passes it becomes cheap. Same thing happened to color TV, same thing happened to PC, same thing is now happening to mobile. Even color prints, I remember when color photography came, used to be 7 rupees per copy, and now it must be very cheap. Now, till 2001, the total power generated, I am talking the whole world, is just 75 megawatt, whereas it is envisaged it may become 15,000 megawatt by 2010. 2010 is not far off, even I am hoping that I will be around. So, I hope to see this 75 becoming 15,000 megawatt. These are the 3 countries in the world where the fuel cell research is in forefront. Hydrogen research also. I mean, Germany, Japan and USA are, barring Japan there is no wind, but US and Germany wind also, as I have been telling you earlier on. Japan of course is the first to bring a fuel car, which I just now told you. We come back to hydrogen again. Of course, hydrogen was used in fuel cells as well, as you have just seen. This is a medium for energy transmission and storage. I was mentioning about scooter. There are books on hydrogen in our center library. If you are getting interested in hydrogen, you can read it. At least there are books which contain a chapter on hydrogen energy that you can always use. Well, electrolysis will give you pure hydrogen, and of course fuel cells can be used. Hydrogen as a fuel is also used in aircraft, automobiles. I already told you about car, scooters, and once it gets used, naturally it will prompt large scale production. See, there is a catch-22 situation. Unless until there is a use, nobody will produce, because it is a commercial venture. If you are producing something, it must get sold, otherwise why produce? And there are problems of storage and distribution. You must be seeing about LPG gas. If you do not handle it carefully, there have been explosions in various kitchens in the world. If it is leaking, if it is not properly closed. So, you have to be careful whether it is a nuclear power, whether it is any even hydro power, thermal power. There are precautions to be taken. Now, let us further study how the power systems grew in India, growth of power systems in India. Of course, we are fairly rich in resources. There are, you name a resource and it is available. But main problem is how to use them meaningfully, judiciously and optimally. You have talent. Where do you lack? You do not know how to channelize it, how to plan your things, how much you should study a particular subject, when you should study. Should you get up in the morning, or you should get up, work late in the night, and so on. You have to plan your life. Every one of us plans our life. We have coal, as I told you, our next 200 years, no problem. We have lignite. Even we have a lot of oil now. We got a lot of oil. There is a Bombay High, there is Assam, Barnaul, and so on. At least we can have 40% of our requirement. We can have our oil. That is a different matter. You do not want to use it and keep it for future use. That is what USA does. USA is self-sufficient in oil. Still, it gets oil from Middle East and uses that and not using their own oil. This I already told you, that hydro potential in India is 84,000 megawatt. We could only tap so far 25%. There are reasons for that. Now, Government of India brought this so called Navratna, the public sector. NTPC came in 1975, National Thermal Power Corporation. They used to employ at least 300 engineers in a year. I remember the interviews used to be on for a month in Nehru Place, and suddenly the requirement has come down, and again it is looking up. Why? We have to add 100,000 megawatt more. As I said, how do you add it if NTPC doesn't open the new plants for power generation? Luckily, they have also entered in hydro now in big way. So, how long this name they can justify, I do not know. It is no longer only thermal. Now, they are going in a big way for hydro, not forgetting that there is a separate corporation for hydro, NHPC, the National Hydro Power Corporation. Then there is a DVC, Damodar Valley Corporation. Of course, Bhakra Authority is separate. All these are generating hydro power in our country. I already told you that with freedom we got only 1300 megawatt total installed capacity 1947, which was nothing. Prior to that, only few pockets during British Raj, just not much electricity was available. With 5-year plan, first 5-year plan in 51, they started planning for generation, transmission and distribution. By the 60s and 1960s, say by 1970, interstate grid system started. Till that time it was only state electricity boards, UP state electricity board, MP state electricity board. So, power could not be given to a neighboring state even if you have surplus. For long years Kerala used to be having surplus power, because Kerala is a very small state and very rich in hydropower. If you travel in Kerala, you hardly find any space there, and all water everywhere. So, there is good irrigation, there is good water, and their economy is also good, because from every house someone is in Middle East and someone is nurse in medical, paramedical. So, they are all educated, 100% education. So, interstate grid means what? They can connect the states, and they produce 5 regions. Which were those 5 regions? I will just show you the map. NREB, SREB, WREB, Eastern Region Electricity Board, and Northeast. Northeast always has a special treatment because they are not so much developed. Now, these SEB, State Electricity Board, got converted into REBs, Regional Electricity Board. Now, next step is, why not interconnect these regions? That is natural. See, if you have become 4-figure salary earner, the next aim will be to become 5-figure, and so on, if you can make further progress. National grid, so far we have been talking from 1980s that we should have a national grid soon, but already 25 years are over and yet there is no national grid in place. However, these 5 regions are now loosely interconnected. So, in a way there is a possibility of power transfer among these various regions. BHEL is manufacturing power plants. Kaiga is the name of a nuclear power plant in Karnataka. BHEL is exporting the power plant. There was a time when we imported power plant from Germany, Siemens, in 70s. Now, BHEL, among stiff international competition, is able to get contracts for turnkey projects to start power generation in several countries in the world, including developed countries. Do not think it is only developing world, because it works out to be cheaper. and in globalization, that is the competition is the name of the game. Now, as promised, this is the map of our country India, and these are the 5 regions. NREB consists of 9 states: Jammu Kashmir, Rajasthan, Himachal Pradesh, Haryana, Punjab, Delhi, Uttaranchal and Uttar Pradesh. Eastern region: Orissa, Bengal, Bihar, and northeast is that Assam, Arunachal Pradesh, Nagaland, etc., etc. Western region is Maharashtra, Gujarat and MP. Of course, now Chhattisgarh. The eastern region also contains Jharkhand, which I forgot to mention. Southern region is same for southern states: Andhra, Karnataka, Kerala and Tamil Nadu. I have given the megawatts installed capacity in these brackets, right, and this is the energy generated as on today. Today means 2002. These figures will change with time, because more and more power is getting added and produced. Now, there, as I said, there are western region is connected to NREB, western region is also connected to SREB. So, there is a tie line through which power can flow either way, depending on which region is having access at a given point of time. Of course, if there is a contractual obligation, then whether it is enough or not, you have to supply, because you have already entered into a contract. So, once it is a contractual obligation, it is not a question of whether you have or not. You have to, you may have a power cut in your region, but that much power you had to satisfy or supply to a neighboring region, because you have already entered into contract and perhaps you have already taken money for that. What is energy conservation? It is even a course in your MTech. Are you undergoing this course now? Maybe next semester? Okay. It is very important. There are books written on energy conservation. Why it is important? It is cheapest new source of energy. If somebody asks you what is the best way of earning money, do not spend. If you do not spend, that money is with you. Same thing, the same logic is in conservation. You conserve energy produced, so it is with you. Cheapest in the sense there is no money. In fact, a dollar saved is more than dollar earned, or rupee, whichever currency. Why? If you earn, you have to pay income tax. If you save, I do not think there is any income tax in most countries in the world. I can't vouch for all countries. There may be some country, hey, why are you saving? Pay some tax. But I am not aware of any such country. That is what it is written here. Energy saved is more than energy generated. Why? If you generate and if you take it to the load center, there will be a loss on the way, whatever be the amount. Let us not go into that. All of you know how much T&D losses are there in our country. But if you save energy, where is the question of any loss? So, 1.25 per unit is equal to, if you save 1 unit is equivalent to 1.25, because you have to generate 1.25 to get that 1 unit, because 25 will percent will get loss on the way. Various conservation measures. This is a big project. In fact, each utility now is forced to go for energy conservation and energy audit. That is why I told you to attend that energy audit course as and when it is run in the evening. It is worth going and attending that 1 hour per week if it is not included in your MTech syllabus. Cogeneration you have already learned. I told you topping cycle, bottoming cycle, why waste that heat, conserve that heat, collect that heat and use it again to generate power. Use of energy efficient motors. All of you must have done a machines course in your 3rd year, 2nd year, depending on your university or your college. You must have seen that motors are being used from fractional horsepower to several 100 megawatt. Throughout the world, you do anything, you need a motor. If it is a vacuum cleaner, there is a motor there, universal motor. Even a shaver, whatever, the fridge, AC, mixer, lathe machine, any machine, workshop, industry, you need thousands of motors being run in the country. Imagine all these motors, if we replace, they are normal motors, if you replace by energy efficient motors, how much energy you will save. Instead of having 70%, 70 to 80% efficiency in a normal motor, the energy efficient motors have efficiencies of 90%. So 10% higher efficiency means 10% less loss. And sigma of that, it is not one motor working. If you take the whole world, my goodness, how many motors are running throughout the world. And all of them, if you do not replace now, as and when the existing motor is outdated, outlived its utility, you are going to throw it, you have declared it, you are going to write it off, as they call it in management terms, Then at that time, while purchasing a new one, at least for God's sake, do not repeat the same mistake of purchasing a normal efficiency motor, but purchase the energy efficient motors. There is full chapters now written on energy efficient motors in latest machine books or drives courses. To avoid wasteful electricity, even simple housekeeping measures can improve, save energy. A 60 watt bulb in our house, why people have to wait for Diwali to clean it, or when it gets fused then you throw it? Why can't you, when you do dusting of your other things, sofa set, central table, why not also have a hand on the bulb? If you clean it, naturally you will get more lumens. Okay, your eyesight won't get spoiled. You will be able to read much more clearly. But we don't do this. Even if you are going for bathroom, you can always switch it off, because it may just possible while coming you may get busy with conversation with someone in the family, and that fan and lights are still on. So these are the important conservation measures. There should be a switch outside every room, whether it is a campus, anywhere, whether it is a institute or a hostel or houses, so that even if you are locked and gone out, another man can come and, like hotels, you can switch it off, otherwise it is on. Oh, everybody has to pay, so it is all right. Any wasteful electricity use should be avoided. Unnecessarily high lighting levels. If you go to any big building, any 5-star hotel, if it is necessary, yes, by all means you have a high lighting levels, like a shooting is on, or it is maybe Diwali, or maybe some important function. But why in a normal daily life? Why should you have a high lighting levels? What for? And especially you are neither reading nor writing anything, just chit chatting. You please understand that each 5-star hotel, the 40% bill of that hotel is for electricity bill. So high is the lighting level. Oversized motor. Selection of motors must have been a very important topic in your utilization of electric energy course, whether you are at Taylor's book or Wadhwa's book or Pratap's book or any book, Star's book. Every book has to talk how to select a motor for a given purpose. Normally you tend to select oversized motor thinking that in future there may be expansion. Who knows when there will be expansion? It may be other way around. You may not get business, you may have to cut down your production. Then it is happening the reverse. Rather than expansion, you are going for other direction. So, this oversized motors which you have designed for a given purpose further gives you losses, and you all understand sometimes working at full load is more efficient. You have drawn efficiency curves, and if you work at half load, you are working. Just now we have talked about energy efficient motors, and now you are yourself not using it correctly. I think all of you know that a 60 watt bulb, 40 watt tube and a 9 watt CFL. What is CFL? Compact fluorescent lamp. Even in trains nowadays you go, you have a fluorescent lamp. Even in houses. Where is 9 watt, where is 40 watt and where is 60 watt? In fact, this 40 watt is 54 watt if you consider the chokes and other things, the wattages. So, the energy consumption gets drastically reduced if you replace bulbs and tubes by CFLs. Now, there is a problem here. Of course, all of them have the same lumen output. I am sure you must have done illumination course in your undergraduate. Luminous intensity, intensity of illumination and so on. The problem is cost. A poor person may not be, but then nowadays cost is coming down constantly. When it started it was 400 rupees, and with Chinese goods coming in, a CFL of the Chinese brand is 40 rupees. What is the payback period even if the cost is more? Hardly less than a year. Few months you are able to recover that extra cost which you might have spent. But there is a harsh reality here. The socio-economic conditions of Indians who are BPL, below poverty line, there are several. The fact is, in most of the houses by 25th of every month, hardly any money is left if you are single earning. Of course, nowadays there is nobody single earning. I am talking about our generation. And then when the house lady says, look, the bulb is fused. Now, you have no money even to bring bulb, forget about CFL or tube. This bulb costs you 10 rupees. This is a separate issue of socio-economic realities of Indian households. But otherwise, this makes perfect sense if you are going to purchase a CFL rather than a bulb. But even today bulbs get sold, the tubes get sold. I am not sure whether you are aware, the Philips came out with thin tube light, and there is a normal tube light, and thin tube light was priced higher initially. And the people used to bang the shopkeeper, don't think that we are fools, you are giving me a thinner, I want that. He used to say, no, this is energy efficient, sir, it is all right, I don't want it. Then they started making the same price for both, and still that much awareness is not there among people that thin was better than thick, because nobody advertises on such issues. You have to use print and electronic media to spread awareness on just celebrating the energy conservation day is not enough, or putting a poster which normally we do in India, speak in Hindi, I will be happy, but nobody speaks. So such posters are just for of no use if you are not going to implement it. Consumption level must be reduced. I have been talking about this, but without lowering the comfort. Don't become blind, don't have such a small bulb that you are not able to read. That is not the intention. The intention is you should be comfortable and yet you are not wasting energy. So, there has to be an optimum mix, the judicious choice. T&D losses in our country are too high and they should be brought within a range of 20%, less than 20%. Imagine how much energy we can save, how much power we can save if you can reduce these thefts, the metering is faulty. Even if you meter, there is no recovery, there is no billing. Even if you bill, bills do not reach the consumer. Even if reaches, consumers do not pay. Even if they pay less. So, these are the problems we are facing in our country. Use technology. So, technology is normally misused. In yesterday TV program, they were showing how just by making an ISD call, you can have a bomb blast anywhere in the world. The circuit gets connected just by making a call. So, why technology is being used for bad purposes? Why not for good purposes? There is a compensation, series and shunt, you might have read already. Just by investing few rupees, if you can save several hundred, several thousand, why not? And the compensation is either series or shunt. This is a transmission line, this is the load, either have shunt capacitor or a shunt inductor, or you can have capacitor here. This is series and this is shunt. What is cost? Just cost of a capacitor, and it will improve 3 in 1, as I said you other day. The power factor gets improved, the efficiency goes up, and of course, voltage control gets better, the regulation is better. So, this SVS static VAR system, SVS static VAR control, SVC should be static VAR compensator, FACTS devices, power factor improvement, voltage control, HVDC option wherever is possible. You should go for HVDC. In our country now, as I told you, from northeast to south, there is a 2000 megawatt corridor they have created for HVDC. HVDC, another use is of course that asynchronous link back to back connection, which is there in Satpura and so many other places. So, you can have a combination of gas turbine and steam turbine, combined cycle. The gas turbine used for peak load and steam turbine for a normal load. Quick automated start and shut down is possible with gas turbines. We do celebrate it several days in our country. Children Day, 14th November, Sadbhavana Divas, Anti-Terrorism Day. So, we also celebrate Energy Conservation Day on 14th of December every year. But this day should be celebrated in such a way that you make people more and more aware what is this all energy conservation about. Energy audit, there is the Electricity Act Bill 2003. How many people talk on this bill? They talk on women reservation or SC, ST or OBC, but where is the media not interested in talking on Electricity Act Bill which was passed, but hardly any panel discussion or anything on this particular bill. Energy efficiency drives regenerative braking. I am sure you must have read braking in your undergraduate. plugging, rheostatic braking and regenerative braking. In traction, electric trains, we have perhaps the biggest railway network in the world, and our terrain is not so smooth throughout India. We have ups and downs. So, whenever we are going down the hill, we should use regenerative braking, like coming from Shimla to Kalka, and you can save a lot of power. Talking about sun, the solar, I told you that we have 270 sunny days and use for bath and kitchen. What our did I tell you what our forefathers, they used to keep a bucket of water in the outside and take bath, whereas we use geyser. We forget that geyser is on, we go and watch TV, read newspapers, even take breakfast, and then geyser is still on. This I think I have told you already, that solar water heaters, hostels, hotels. Are you aware that in Shivalik Hostel the Energy Center has put in solar water heater there? You should be going and seeing that. You may ask me a question, what do you do with the solar water heater in summer? Well, wash your utensils in the mess rather than cleaning them with cold water. Hygiene is always a question mark. So, it will be better if you wash those utensils with hot water, which is available free of cost in summer days. Similarly, I told you about hospitals and commercial buildings and so on. Now, we use inverters, the inverters use have gone up. Do you realize most of us have only 2-room set houses, Barsatis, the majority of us. Even you are facing the music now, having 3 students in 1 room. Where is the space to move even? You may not be having, but undergraduate students do have to stay like that, or an IP hostel or somewhere. I was told in even warden's house some 16 girls have been put in Kailash, is it right? So, space is a problem. And then if you have an inverter, I am sure you can't sleep in that space, in the room where you put. If you put outside the house, tomorrow you may not find it. So, you have to put it inside the house, and whichever room you put it, since the fumes come, the gases come, there is a acid, I do not think you should sleep. Even some research has been done on those mosquito nets and all those things. There are fumes coming out and you inhale them. I am sure it is not a room freshener, or it is not a deodorant, which nowadays every person is using in different quantities, different frequencies. So, inverter is a must, and yet it is again a health hazard. Do not think only bottled water or Coke or Pepsi is having parasites. So, pollution, space, cost, wasteful energy devices. So, use solar energy inverter. It is available in 1600 rupees, again available in that shop, Aditya shop. 2 bulbs, 2 fans can be used with that, and it gets automatically charged in sun. I also want to tell you the photovoltaic PV is being used in night time in Rajasthan on camelback. Why? You get a light because it is dark, the electricity has not reached villages, I told you, and in dark you can't go, it is safer, you are secured also. In fact, in Kargil war, the Pakistani soldiers used PV jackets, whereas our soldiers were not having proper shoes. Where is the question of PV jackets? That keeps you warm. So, the photovoltaic has applications in every walk of life. Maintenance, I have already talked about it some time back. The downtime of plants will decrease. I told you the bathtub curve also, and the plant utilization factor will go up. If the plant is down, naturally you are not able to use it. If your car is not available, it's staying in garage more number of days than in your garage, naturally what is the use of spending 2 lakhs? So, that should be available to you most number of days rather than you should find parking in workshop. Load management is a very important topic. There is a paper of 60 pages by Talukdar on load management. Anybody who wants to know more about it, the reference I have given in my book, first chapter in the end, and read that paper in case you want to do more work on energy management, load management. The management has become very important along with IT. Everybody wants to have a BTech degree in computer science from an IIT and then MBA, if not from Harvard, from IIM, if not Ahmedabad, Lucknow. So, this load management, energy management, you can shift demand from peak hours. We have already talked about those 5 golden rules, and then modified tariff structure. The tariff has to be modified. We will talk more about it on Friday, about the modified tariff structure, how we have to restructure it, and with privatization it will be possible. So, now I will ask, I will request you to have any few questions or clarifications or suggestions on whatever we have covered today. Do you have any?
So, by downtime of plants we mean the repairing time?
No, downtime means when the plant is not available for generation, and of course, that includes time of repair also, because while repairing also the plant is not available, and it depends on you how much time you take to call repair team if you do not have one. Sometimes you may not have in-house, because now it is an era of outsourcing. That is what US has started doing. It has started giving their problems to India rather than calling Indians there. They found it cheaper. That is why our security also outsourcing. Everything will be outsourcing nowadays, because then you do not have to spend that much money. They are not your employees. Yeah, any other question?
Sir, what are these energy efficient motors?
Well, energy efficient motors will have a better cooling, better insulation. So, more that is why they are costlier, because you are putting in so that the losses gets minimized. There is no other magic that just by calling them energy efficient motors they will have more efficiency. That means you have to change the design, okay, and it itself is a very important and fascinating topic, and please read any modern machine books, maybe PC Sen or maybe Fitzgerald's 6th edition, even our book, machines book, I do not know whether you are aware, it also now talks more detail about energy efficient motors. So, well, ladies and gentlemen, I must thank you for today, and we will see you on Friday.